In today's video, I would like to introduce a very nice problem. It's coming from Croatian Mathematical Olympiad edition 2001. Here is the following information. For all x as a natural number associated with p as a prime, satisfy this following equation. We have a double x squared minus x minus 36 equals p squared. Okay, so it's more clear here. It's not hard equation to solve. Just you guys, you can give the hands to this one, pretty good solution. God pause this video when you come back to this solution. Okay. By the way, don't forget to hit the subscribe button and support the channel by like, comment, and subscribe. Now let's jump into the solution to see what's this one going to be. Okay. Notice here you may have different methods you can apply here. Now let's go to the easiest method of this one. So if I'm going to factor out this one, I will be end with x plus 4 factor 2x minus 9, which equals p squared as a prime. Okay. Notice here, if I'm going to deal with the GCD in this case, so we know GCD of this one equals 1 or p, because we have a prime. A prime is going to be divisible by number 1 or prime itself. Okay. Same thing with the left hand side of this equation. Since this one is a prime, which means the GCD of this one is going to be number 1 or p. Okay. Let's notice that. So the GCD of these two terms is going to be 1 or p. Let's go through two cases. Case number 1, if GCD of the x plus 4 and 2x minus 9 equals number 1. So what's gonna happen here? I'm going to get some information about this combination linear. So if you take a look here, this one is verifying the basic theorem because this will have a combination linear here. So let's go through the theorem. For all x and y as integers, there exist a and b as integers as well. Satisfy this following equation: x a plus y b equals GCD of a and b, which equals number 1. Okay, it's more clear. So notice here, but we have a minus sign here. So let's change this minus plus sign into the minus sign and change this one into this integer into the natural number. Because when you have the integer here, so which means you are dealing with a general expression. Okay, so when you put a minus sign, you are going to fix the condition. You have to take this one as a natural number, because since b is a natural number, it's not going to be change the sign. The only thing can change the sign is y. Okay, because this one is an integer. So let's also, since I got minus sign here, since we get number 2 and a, let's replace a and b with them 2 and 9. 2 and 9. It's more clear. That's true, because the GCD of 2 and 9 equals 1. Okay. Now, what does this mean? This one, it will be divisible by number 1. It cannot divisible by p, because if divisible by p, it wouldn't have GCD equals 1. Also, we will have GCD equal p. In this case, since GCD equals 1, but we are dealing with GCD equals 1, which means this one is going to take number 1. So the other one is going to take the whole thing, p squared. Okay? So which means x plus 4 is going to take p squared. The other one, 2x minus 9, is going to take number 1, which equals p squared. Okay? Because for the GCD equals 1. Okay, so what does this mean? I'm going to replace this one with number 1, so I get 2x minus 9 equals number 1, and this term, which is x, and this term x plus 4 is going to take the whole thing, p squared. Let's get x out of here. You get x equals 5, because after you taking minus 9 to the right, I get 10 here over 2, which is 5. Let's take this 5 and insert it back into this one. So I get p squared equals 9. Since we have a prime here, p equals 3. So this is just the first case. Now I have extracted the first solution. X equals 5 correspond with p equals 3. Let's go through the second case. Okay. Second case, if the GCD of this one equals p, what does this mean? What does this mean? That means both of these terms are sharing p as a common divisor, which means this one is going to be p, the other one is p. Okay, which means I will have p factor p will be replaced with x plus 4 other p will be replaced with 2x minus 9. It's going to give us the whole thing p squared. Okay, so in this case GCD of this one equals p, because this one is divisible by p as well as this one. Okay, so now let's replace this one with p and this one with p. Okay, so I get here x plus 4 equals p. Same thing, 2x minus 9 equals p. So let's take this equation equals this one because we have equality. Okay, so I get here x plus 4 equals 2x minus 9. Thus I'm going to move over x variables to one side and the constant to the other side. I will be ended with x equals 13. Okay, x equals 13. I'm simply going to take this value of x and insert it back into either equation. Okay, I will have x plus 4, which is 17. I will be ended with p equals 17. So which means I have the second solution, x equals 13 correspond with p equals 17. Okay, this is the first method that I have chosen by using the GCD. Now let's get rid of this stuff and move on to the second method. Guessing and checking by previous arguments, we found the solution x equals 5, p equals 3, and x equals 13, p equals 7. In this case, I'm going to assume we have a solution. In this method, I'm going to assume we have the solutions above these solutions. Then we will have a contradiction. At the end, we have no solutions. The only solution we can find just this one. Okay. But by the way of contradiction, suppose x is strictly superior than 13, p is strictly superior than 17. This one implies x is going to take 13 plus 2 and p is taking 17 plus 2m. Okay, we know x is odd by previous arguments. This one is odd. Okay, so which means x must be odd as well. Okay, so if x is odd, we are going to keep the oddness here by adding the even term. Okay, regardless of number 14, x equals 14 is not going to be a solution, so which means we are going to consider this one on this form. Okay, as well as this one. Now what to do? I'm going to deal with the power of p. Actually, this one I'm not going to use it now. I'm just going to use this one as a power of p. Okay, so let's transfer this one into the equation system. So I get here x plus 4 is going to take p to the a, and 2x minus 9 is going to take p to the b. Okay, so now the question, when this one becomes bigger than this one b is strictly superior than a, implies when we have x is strictly superior than 13. Okay, because if you replace x with 14 here, I get 18. 28 minus 9, I get 19, which means this one is bigger than this one when we have this condition. Otherwise, you will have this one bigger than this one. Okay, this is very important condition. Okay, what to do? I'm going to multiply the first equation by number 2. So I get here, if I'm going to do that, I will have a new equation system. So I get 2x plus 8, which equals twice p to the a, and this one I get 2x minus 9, which equals p to the b. I'm going to cancel out x by putting this equation minus this equation. So I get 8 minus 9, which is 17. Then this equation minus this equation, I will have 2 p to the a minus p to the b. Okay, so after multiply number 2 by the first equation, this one becomes bigger than this one. Okay, if this one bigger than this one, which means this one is bigger than this one. Okay, so which means I'm going to take p to the b as a common factor here. So I get p to the b factor 2 p to the a minus b minus number 1, like this. Okay, since we have 17 is a prime, which means this one must be a prime as well. Is going to take number 17. It's impossible to take number 1 because we have only two choices. We have number 1 and 17. One term is going to take number 1, the other one is going to take the prime itself, 17. Okay, this one cannot take number 1 because it's a prime, which means it's going to take number 17. So if this one is going to take number 17, which means I get p to the b, p equals 17. B is going to take number 1. Okay, b is going to take number 1. So implies this term is going to take number 1, which means 2 to the 2 is multiplied by p to the a minus number 1, which equals 1. Okay, thus 2pa equals 2. Okay, in the other words, p to the a equals 1. A equals 1. If a equals 1, it's impossible, because we have contradicted our assumption. Our assumption was b is strictly superior than a, but we found a equals b, which is impossible. Okay, because we found a equals 1, b equals 1, which is impossible. We have contradicted our assumption, which means we have no solutions for this equation. We have x is above this point 13, which means the only solution that we can get this one. So we will have the set x belongs to 1, 2, 3, 4 all the way down to the 13, which means number 5 and 13 are the solution for this equation, which we found before. Okay,